Okay, this video is for number 2 on stoichiometry worksheet number 6. Number 2 says the industrial production of ammonia, or NH3, proceeds according to the following equation, and then we are given this balanced equation. Part A asks what volume of nitrogen at standard temperature and pressure is needed to react with 57 liters of hydrogen measured at standard temperature and pressure. So the problem gives us 57 liters of hydrogen. Remember that hydrogen gas is a diatomic, so it would be H2. And then it wants to know what volume of nitrogen is needed to react totally with this. So the problem is really asking us to convert from liters of hydrogen to liters of nitrogen. If we use the molar map, we can see that the first thing we need to do is convert from liters of hydrogen into moles of hydrogen. So, in order to do that, we are going to use the volume of 1 mole of gas at standard temperature and pressure. Remember that for any gas, it doesn't matter what the gas is, 1 mole of that gas is equal to 22.4 liters. So we're going to use this in order to set up our first conversion factor. We need to cancel out liters of hydrogen, so we're going to put liters on the bottom here. So 22.4 liters of hydrogen is equal to 1 mole of hydrogen. So since those two things are equal, that's why we can set them up this way. The next thing that our molar map tells us to do is convert from moles to moles using the mole ratio. So we'll have moles of something on top and moles of something on bottom. We started with moles of hydrogen, and the problem is asking us to convert, we started with liters of hydrogen, and the problem is asking us to convert to liters of nitrogen. So we need to put nitrogen on top and hydrogen on bottom. This way hydrogen will cancel out and we'll be left with nitrogen. We pulled the numbers for the mole ratio from the balanced equation. The coefficient on hydrogen is 3. The coefficient on nitrogen is 1. The next thing that the molar map tells us to do is to convert from moles back into liters. And again, we can use this same equivalency that 1 mole of a substance will be equal to 22.4 liters of that substance if it's a gas at standard temperature and pressure. So what that means is that 1 mole of nitrogen will be equal to 22.4 liters of nitrogen. Now if we go through and we start canceling out units, I can see liters of hydrogen, moles of hydrogen, moles of hydrogen, moles of nitrogen, moles of nitrogen. The only unit that does not cancel out is liters of nitrogen, which is what the question's asking us for. So we can do our math and multiply across the top and across the bottom. I'm going to type everything into my calculator at once using the fraction function. 57 times 1 times 1 times 22.4. I'm going to exclude the ones. 22.4 times 3 times 1 on bottom, so 22.4 times 3. That gives us 19 liters of nitrogen as our answer. So what this means is that if we want to totally react 57 liters of hydrogen, we need to also use 19 liters of nitrogen. That was for part A. Part B says what volume of ammonia at standard temperature and pressure can be produced from the complete reaction of 6.39 times 10 to the 4th liters of hydrogen. So this problem is set up in much the same way, except it's asking us for a different substance at the end. We're starting with 6.39 times 10 to the 4th liters of hydrogen, and the problem wants us to convert into volume of ammonia. So we're going to work this the same way. We're given liters of hydrogen, so the first thing we need to do is use this equivalency to convert that into moles. So 1 mole of hydrogen is equal to 22.4 liters of hydrogen. Again, we put liters of hydrogen on the bottom so that will cancel. The next thing that we're going to do is use our mole ratio to cancel out moles of hydrogen. So we put moles of hydrogen on the bottom. And the thing that we're converting into is moles of ammonia. So we put that on top. And again, we're going to pull these numbers from the balanced equation. 2 with ammonia and 3 with hydrogen. Those numbers are from the balanced equation, the coefficients in the balanced equation. Next, if we're looking at the molar map, it tells us that the last step is to convert from moles of ammonia into the volume in liters. And again, we use this equivalency to set that up. 1 mole of ammonia will be equal to 22.4 liters of ammonia. And again, at this point, I always like to check and make sure that everything cancels out except for what I'm looking for. So liters of hydrogen cancels, moles of hydrogen cancels, moles of ammonia cancels, and the only unit that is not canceled out is liters of ammonia, which is what the question's asking us for. Now we can go through and do our math just like in part A, and I'm going to use the fraction function again. On top, we're going to type in 6.39 times 10 to the 4th. If you wanted to, you could convert that into a regular number first. Times 1 times 2 times 22.4. So I'll just do times 2 times 22.4. That's all going to be on top. Now on bottom we have 22.4 times 3. Oops. 22.4 times 3. There we go. And that gives us 42,600 liters of ammonia. Now we could convert this into scientific notation, which would be equal to 4.26 times 10 to the 4th liters of ammonia. Okay, so that was problem number 2.